Alright, in this video we're asked to identify the voltage across each resistor in the following DC circuit. So in order to do that, we're going to use Kirchoff's laws of voltage and current in order to form a set of three equations with three unknowns and solve that system simultaneously for each voltage. Now, first, I'll label the orientation of the current flow in this diagram. So across this top left resistor, it'll be like so. Across the top right resistor, it'll be like so, flowing from positive to negative. And with those two currents going into that central node on top, I'll call this node A. The resulting current will be flowing down through the central resistor. So the orientation will be like so. I'll also go ahead and label each of the loops that are going to be used in Kirchoff's Kirchoff's voltage law analysis. So we'll label this loop B, and we'll label this loop C. I'll also go ahead and label the resistors. This will be resistor 1 with voltage 1, resistor 2, voltage 2, resistor 3, voltage 3. Now I'll start by writing the KCL equation. Kirchoff's current law at A states that I1 plus I2, the currents flowing into node A, is equal to I3, the current flowing out of node A. We know from Ohm's law that V is equal to IR. And since we're asked to solve for voltages, I'm going to rewrite this first equation in terms of voltages. So I will be equal to V divided by R. So if we rewrite the equation, we get V1 by R1 plus V2 by R2 equals V3 by R3. Now, since all the resistors have the same resistance value, we can multiply both sides of the equation by that value and cancel out each of these resistance values. So if I rewrite this equation once more, and I'm going to write it in such a way such that all of the voltages will be on one side of the equation, see that V1 plus V2 minus V3 equals 0. Now I wrote it that way with the voltage terms on one side purposefully because later on it will help us understand how to set up a matrix equation to simultaneously solve this system of equations rather easily and simply. So now we'll proceed to Kirchoff's voltage law for loop B. So the rises equals the drops. So 10 volts is equal to V1 plus V3. As we go around this loop, we have a voltage rise of 10, a voltage drop of V1, and a voltage drop of V3 before returning back. Similarly, for KVL-C, we have a rise of 30, a drop of V2, and a drop of V3. So I'll write KVL-C, 30 volts equals V2 plus V3. Now you can see each of these equations has the voltage terms on one side I'm going to rewrite them over here. So we can see a little bit more clearly how to set up this matrix equation. V1 plus 0 plus V3 equals 10. 0 plus V2 plus V3 equals 30. Now I wrote zeros for voltage terms that don't exist in the voltage side of the equation. I did that because you can represent this system of equations as a matrix equation and simultaneously solve for each term in the equation without the need for a bunch of substitution. So when you rewrite these three equations in terms of a matrix, you write the coefficients of the voltages, so 1, 1, -1. That first row corresponds to coefficients of this equation. Next row will correspond to the second equation. 1, 0, and 1. And the last row will have 0, 1, 1. 0, 1, 1. Now, this gets multiplied by a 3×1 vector of our unknowns. And this expression will be equal to the constants on the right-hand side. Now there are computer tools and even tools on your calculator that can solve this rather easily. My calculator is a Casio FX991EX, and it will solve this system of equations with 3 unknowns. Now I'm going to type that in. And I get that my voltages -3.3 for voltage 1, 16.7 for voltage 2, 13.3 for voltage 3. And those are volt units. So you can see, since I got a negative voltage for voltage 1, that means the orientation that I assumed for the direction of current flow in this resistor is actually opposite. So here are our answers. Thank you for watching, and please subscribe to this channel if you're new. Help build this channel and grow the curiosity of those wishing to grow their skills in engineering, science, mathematics. Thank you and have a great day.